So, um, imagine you are standing right in front of a house.
Okay.
Like, it looks massive,
Oh.
right? Towering totally over you. But if I'm standing, say, a mile down the road, to
Mm.
me, that exact same house looks tiny.
Right. Yeah.
And the house didn't physically shrink?
Yeah.
I mean, our
Yep.
perspective just changed. Now, what if I told you time works the exact same way?
That is the ultimate mind bender, honestly.
It really is. So pull up a chair, grab a drink, and, you know, get comfortable.
I am just so glad you're here hanging out with us because today's deep dive is tackling something that, well, every single one of us deals with every second of the day.
Yeah, and yet we almost never stop to actually understand what it is.
Exactly. We are talking about time. Specifically, we've been digging through this really fascinating stack of notes from a January 31st exchange. And, I mean, it takes an absolute sledgehammer to everything we think we know about reality.
It really does. It's
Yeah.
wildly brilliant. So the core mission of this deep dive, like the main question the three of us are going to try and answer today, is this. Is time a constant universal flow that is just chugging along in the background and we just happen to perceive it differently? Or is time itself physically shifting and like bending around us?
Which is just a massive question. And it's great to have you joining us for this, because this isn't just, an abstract thought experiment. This
Right.
gets to the very foundation of how the universe operates. But before we get into the really cool philosophical pushback we're exploring today, we kind of have to establish the baseline.
Yeah, absolutely.
We need to clearly define what modern physics actually says about, like, the mechanics of time.
Okay, lay the groundwork for us. What is the accepted scientific consensus before we start tearing it all apart?
So the consensus rests really heavily on Albert Einstein and his theory of special relativity.
Okay.
Because before Einstein, the prevailing thought was exactly what our human intuition tells us, right? That time is an absolute ticking clock that exists totally outside of us.
Like a universal metronome or something.
Exactly. Just ticking at the exact same rate everywhere in the universe. But Einstein demonstrated that time is entirely relative.
Right, but how? Because that's the part that always feels like magic to me.
Yeah.
Like, why does time have to be relative?
Well, it all comes down to the speed of light. The universe has a hard speed limit.
Okay.
Light travels at about 186,000 miles per second, and that speed is absolute. It literally never changes, no matter how fast you're moving when you try to measure it.
Wait, really? It never changes?
Never. But think about it. Speed is just distance divided by time, right?
Right.
So if the speed of light is completely inflexible, something else has to flex to make the math work.
Oh, wow.
Yeah. And Einstein realized that the things that flex are space and time itself. So the passage of time actually differs depending on the observer's frame of reference. And that's driven by two major factors: velocity and gravity.
Okay, so velocity first. This is the classic astronaut example, right?
Yeah. Exactly. Time dilation. If you have an astronaut traveling in a spaceship at somewhere near the speed of light, that astronaut is going to experience time much more slowly compared to you and me sitting back here on Earth.
Because they're going so fast.
Right. Because they are moving so fast through space, their movement through time has to slow down to compensate, just to keep the speed of light constant.
So their clock is literally ticking slower. I mean, it's not just a perception trick.
Not at all. It is a mechanical reality.
Mm-hmm.
And then the second factor is gravitational time dilation.
Right, gravity.
Massive objects actually warp the fabric of space-time around them. Think of space-time like a trampoline, and you just drop a heavy bowling ball right in the middle.
Okay, I can picture that.
The fabric dips and stretches down around the ball. That stretch is gravity. And because the fabric of space and time is stretched closer to that mass, time basically takes longer to cross it.
Oh, I see.
Yeah, so if you place a clock closer to a massive, heavy object like a planet, or at the extreme end, the event horizon of a black hole, that clock is going to tick significantly slower than a clock situated further away in deep space.
Okay, let's unpack this.
Sure.
Because this is exactly where the arguments from the January 31st material get so incredibly compelling.
They really do.
The logic here pushes back on that whole consensus.
Oh.
It argues, like, if time changes based on the viewer's velocity or the viewer's gravitational situation, doesn't that inherently mean that time itself is the constant and it's actually the viewer who is changing?
It's a very clever way to organize reality in your head, but...
No, hear me out, because there's this brilliant ruler analogy in the notes to drive the point home.
Okay, let's hear it.
Imagine two people are trying to measure the exact same object. One person is using a ruler that says the object is 10 units long.
Right?
The other person is using a different warped ruler, and their ruler says the object is 5 units long. the object itself didn't magically change its shape or size.
No, of course not.
The measurement tool changed. The conditions of the observation changed. So when we talk about astronauts going fast or someone hanging out near a black hole, aren't we just talking about their ruler getting warped by gravity or speed?
I see where you're going with this.
Like, why do we assume the fabric of time itself is bending rather than just the physical tools we use to measure it?
I will admit, I really like the elegance of that argument. It tries to, separate the viewer effect from the actual physical phenomenon,
Right.
but the physics breaks that down pretty quickly. The scientific census says that time isn't just subjective, it's an objective physical dimension of space-time.
Yeah.
When you say time changes, we aren't saying the observer's atomic clock just got a little glitchy because gravity squeezed its physical gears. We are saying time itself genuinely alters, and, we have thoroughly tested this.
Tested it how, exactly?
Well, let's look at the famous Hafele-Keating experiment from 1971, which is just a perfect example. Physicists literally bought commercial airline tickets for highly precise atomic clocks.
Wait, they just put atomic clocks on regular passenger planes?
Yes. They synchronized these clocks with identical reference clocks on the ground. Then they flew the airborne clocks completely around the world, first eastward, then westward.
That sounds like a logistical nightmare in 1971.
Oh, it was incredibly difficult. But the results were undeniable. When the planes landed, the clocks on board no longer matched the clocks on the ground.
No way.
Yeah. The ones that flew eastward in the direction of the Earth's rotation were moving faster relative to the Earth's center, and they actually lost time.
Like they recorded less time having passed.
Exactly. They genuinely experienced less time than the ground clocks. It wasn't a mechanical failure. They measured the actual stretch and compression of reality.
Wow, and we do this with our phones now too, right? With GPS.
Yes, exactly. GPS atomic clocks are the modern equivalent of that. The satellites providing GPS for your phone are moving incredibly fast, and they are further away from Earth's gravity well.
Right, so less gravity.
Yep. So because of both their high velocity and the weaker gravity, time literally passes at a different rate for them. If engineers didn't program those satellites to constantly calculate and correct for that physical time difference, your GPS would drift by miles every single day.
That is wild.
So the universe isn't just messing with our rulers. The space-time fabric is real.
Okay. I hear the physics, the planes, the atomic clocks, the satellites. It sounds completely airtight.
It's pretty solid.
But, and I want you listening to this to really chew on this with me for a second, what if definitive science isn't as final as we like to pretend it is?
Oh, here we go.
I'm serious. I'm looking at this argument from the notes, and I'm honestly not entirely satisfied by those experiments. Because the point being made is that everything we currently call concrete and measurable is absolutely bound by the limits of our current technology and our conceptual frameworks.
What's fascinating here is that you are shifting the focus from the mechanics of gravity to the limits of human observation.
We have to. Because if you look at the history of science, we have this really embarrassing habit of being definitively, absolutely verified, right up until somebody invents a better microscope.
That is very true.
We used to have Ptolemaic astronomy, which said with total mathematical certainty that the Earth was the center of the universe. And the wild thing is, the math worked.
Right, for what they could observe.
Exactly. For what they could see in the sky at the time, their equations predicted the movements of the planets. It was considered concrete. Then we had Newtonian physics, which was the undisputed law of reality, until Einstein came along and realized it fell apart at high speeds.
That is a fair point. What is deemed concrete is completely relative to the era you live in.
Exactly, and there's this fantastic historical example in the material about spontaneous generation.
Oh, I love this one.
It's so gross,
Yeah.
but so good. There was a time when top-tier, highly respected scientists genuinely believed that if you left a piece of dead meat out on a table, it spontaneously generated maggots.
It's just out of thin air.
Yeah, that life just poofed into existence from dead matter. Or they talked about little beasties just appearing. They didn't have the concept of microscopic organisms or flies laying invisible eggs.
Right, no microscopes.
To them, the verified science was that dead meat creates life. It made total logical sense based on the tools they possessed.
Because they just lacked the lens to see the underlying mechanism.
Right. So when we look at gravitational time dilation and we confidently declare the atomic clocks on the airplanes prove the fabric of time is bending, couldn't that just be our modern version of spontaneous generation? Like, what if time actually is constant and gravity is interacting with our atomic clocks and matter itself in a way that is much weirder and more nuanced than our current models suggest. What if we just haven't invented the right microscope yet to see how the meat actually gets the maggots, so to speak?
Well, I don't think Einstein would appreciate being compared to maggots on meat, but your skepticism is entirely valid. In fact, questioning these assumptions is the absolute core of scientific progress. The scientific community would actually agree with you that our tools constrain our observation.
They would.
Oh, absolutely.
Right.
Our current models of physics, general relativity, and quantum mechanics famously do not play well together.
Oh, right. They kind of contradict each other at extreme scale.
Exactly. We know for a fact that our current model is an incomplete approximation of a much more complex reality. So questioning those absolute truths, like challenging why the Hafele-Keating clocks behaved the way they did, is exactly how we will eventually move past Einstein.
It just feels arrogant to assume that in the year 2026, we've finally hit the absolute bedrock of reality.
It is arrogant. And that is exactly why I find the pivot in our source material so compelling.
Yes.
If our scientific tools are inherently flawed and restricted by our era, maybe we shouldn't just be looking outward into the cosmos with telescopes and atomic clocks to understand time.
Right.
Maybe we need to look inward at the very mechanics of how we biologically and metaphysically experience it.
Yes. Let's get into the biology of time, because this is the concept that completely rewired my brain.
It's a trip.
Think about the human body. We have eyes and an optic nerve to process light. We have ears and eardrums to process sound waves.
Right.
We have a complex nervous system to process touch and temperature. But humans do not actually have an organ to measure time.
We have biological rhythms like circadian rhythms, but you're right, we have no specific sensory receptor for the passage of time itself.
None. We literally do not feel time. What we feel, what we actually observe, is entropy.
The second law of thermodynamics.
Exactly. The universe is constantly moving from order to disorder. We see things changing. We see a coffee mug fall off a table and shatter into 100 pieces, and we never, ever see those pieces spontaneously reassemble back into a mug.
Sadly, no.
We watch a hot cup of coffee cool down. We see our skin wrinkling. We see buildings decaying. We are observing the physical breakdown of the universe entropy, and we just slap the label time on it.
Wow.
But that is just a biological limitation. We are using entropy as a proxy for time.
It is a profound shift in perspective. You aren't experiencing a river of time flowing past you. You are merely experiencing the degradation of matter around you.
And once you realize that our biological experience of time is essentially an illusion built on entropy, it opens the door to some incredible ideas.
It really does.
Here's where it gets really interesting. There was an assertion here from Edgar Cayce. Now, Cayce was known as a mystic, not a physicist, but his concept maps flawlessly onto modern physics.
It's surprising how often that happens.
Yeah, he suggests, what if everything exists everywhere all at once? What if all of history, everything that has ever happened and everything that ever will happen, is occurring in one beautiful moment of expression?
One beautiful moment.
Right. We aren't watching time pass. We are just moving through it.
Cayce was approaching it from a metaphysical angle, but as you said, this maps perfectly onto a deeply respected framework in physics called eternalism, or the block universe theory.
Okay, please explain the block universe, because the mechanics of it are wild.
Think of it like an old vinyl record. If you hold a vinyl record in your hands, the entire song exists simultaneously. The intro, the chorus, the outro, they are all physically pressed into the vinyl at the exact same time.
Right, they're just grooves on the disc.
Exactly. The intro hasn't vanished just because it's over, and the outro isn't some unformed void waiting to happen. The whole song is there. Our consciousness, our experience of the present moment, is just the needle on the record player moving through the grooves.
Oh, man.
We experience it linearly, second by second, but the entire landscape of the song already exists.
So dinosaurs, you and me, sitting here right now, and flying cars in the year 3000, they're all just different grooves on the same record.
Exactly. In the block universe, past, present, and future are just different coordinates in a four-dimensional landscape.
That is just hard to wrap your head around.
And the material we are exploring also bridges this to the concept of interconnected consciousness, drawing parallels to quantum mechanics.
Right, the quantum superposition stuff.
Yes. In quantum physics, there is the observation effect. If you fire a quantum particle, it doesn't just take one path. It exists in a superposition. It is essentially taking every possible path at once.
Like it hasn't decided yet.
It exists as a wave of probability. Think of a coin spinning in the air. It's a blur of both heads and tails simultaneously. But the exact moment you observe it, the moment you measure it, the wave function collapses.
The coin lands.
Exactly. The particle is forced to pick a single state.
So the act of looking at the universe forces it to behave.
Precisely. The observer is fundamentally intertwined with the reality being observed. If we apply that quantum logic to the block universe, our consciousness isn't just passively writing the needle on the record player.
Wait, really?
Yeah, the interaction of our consciousness with the universe might be what renders the present moment out of that simultaneous landscape of time.
Okay, so let me ask you listening right now.
Yeah.
If we connect all this deep physics to the bigger picture, how does it change your Tuesday morning commute?
That's the real question.
If you view your entire life as a single, fully pressed vinyl record, rather than a ticking clock running out of sand, does it relieve the pressure?
It should, a little bit.
Does it make a terrible day feel less overwhelming, knowing it's just a fixed coordinate on a map you were traveling across?
It certainly reframes our anxieties. If the past and future are just as real as the present, we are just exploring a territory.
I love that. Exploring a territory.
Yeah.
But it leads to a really massive question.
Okay.
If time is a territory, if it's a landscape we are exploring, what is that landscape actually made of?
Nah.
The arguments we're dissecting bring up a highly nuanced distinction that I need you to break down because it challenges the very fabric of how I understand reality. The author asks, what is the actual difference between space-time and time-space?
Yeah, that's a big one.
I've heard of space-time my whole life, but time-space sounds backward.
It sounds backward to our intuition, but it is a monumental conceptual leap. Let's break down the mechanics of these two opposing frameworks.
Please do.
In the traditional model, space-time, space is the primary framework. Think of space like a giant, empty, three-dimensional room. It exists on its own.
Okay, got the room in my head.
Time is just a fourth dimension added into that room so that objects can move around and interact within it. In that model, space is the foundational boss. Time is just a feature of it.
Okay, that makes sense. That's the universe we are all taught in high school.
But in the alternative framework, time-space, that hierarchy is entirely flipped.
Flipped how?
In time-space, time is the fundamental organizing principle of reality. Time is the boss. In physical space, the distance between you and me, the distance between the Earth and the Sun, isn't an empty room that already existed.
Then what is it?
Space is something that simply emerges from temporal relationships.
Wait, space emerges from time. How does that even work mechanistically?
Think of a massive open-world video game.
Okay.
When your character is standing in a village and you look at a mountain miles away on the horizon, that mountain doesn't actually exist physically inside your computer's memory as a fully formed place yet.
Right, the system hasn't loaded it.
Exactly. The game engine only renders the details of that mountain as you take the time to walk toward it. The distance, the physical space between the village and the mountain, only exists because it takes a certain amount of time for your character to interact with it.
Oh, wow.
In a time-space universe, physical distance is just an illusion created by the delay in interaction. Without time, there is no space. Space is just the byproduct of time taking a moment to connect two things.
That is staggering. So if everything could interact instantaneously with zero time delay, all of space would just collapse into a single point.
Exactly. The scale of that idea is profound.
It really is. I mean, it perfectly encapsulates the joy of digging into these topics.
Yeah.
It highlights just how incredibly limited our everyday understanding of the world is.
Oh, absolutely.
We walk around so confident in our reality. We complain about traffic. We worry about deadlines. We measure our lives by the calendar.
We stress over the little things.
Yeah. And meanwhile, the actual physical space between our car and the office might just be an emergent illusion generated by a video game-like temporal engine built on a vinyl record where our birth and our death have already been pressed into the tracks.
It's wildly humbling.
It really is.
It is the ultimate exercise in intellectual humility, and it brings us full circle back to why we have to question the things we call concrete.
Right.
The more we look at the mechanics of the universe, whether it's through the lens of a commercial airline flying an atomic clock or the lens of quantum superposition, the more we realize we are just barely scratching the surface of how reality operates.
So let's bring this incredible journey back down to Earth for a minute.
Good idea.
We started by unpacking Einstein and the mechanics of why a constant speed of light forces time and space to bend around black holes and speeding astronauts.
We did.
We explored our own history of scientific arrogance, reminding ourselves that atomic clocks might just be our modern version of believing dead meat spontaneously generates maggots and beasties.
Just the absolute limit of what our current tools can show us.
Exactly. And finally, We moved past the biological illusion of entropy to arrive at the beautiful, mind-bending block universe, where space itself might just be a rendering trick created by time.
A pretty good summary.
I think the biggest takeaway here, for all three of us, is actually a deeply comforting one.
Oh.
The next time you are feeling stressed out, rushing to a meeting, or anxious about running out of time, take a deep breath.
Yeah.
Remember that you are just a biological organism measuring the decay of entropy, traveling as a wave of consciousness through a universe where everything might already be happening all at once, in one beautiful moment of expression.
That is a wonderful way to synthesize everything we've covered today.
Thank you.
But before we sign off, I want to leave you with one final provocative thought to chew on.
Ooh, all right. Let's hear it.
It builds directly on that idea of the vinyl record, the block universe theory. If all moments in time, past, present, and future, already exist simultaneously in a fixed, unchangeable landscape, what does that mean for our concept of free will?
Oh, wow.
Are we actually making choices every single day, carving out our destiny? Or are we just passengers riding along a pre-drawn path, experiencing a song that has already been entirely recorded?
Oh, man. Are we the needle or the groove?
Exactly.
That is the absolute perfect question to keep us up tonight. Thank you so much for pulling up a chair and hanging out with us for this deep dive. It is always a privilege to explore these massive ideas with you. Until next time, keep questioning your reality and have a great rest of your day.